Hello guys, so in this video I will be talking about the main change which I made in the YMFC-32 autonomous quadcopter flight controller and made the Hawk32. Now the main change, as I told in the previous video I made, was the telemetry system. I changed the telemetry system circuit in order to work with any RF module you want. So as you can see, my telemetry here is working. S10. Here is the longitude and latitude. I will quickly show you by changing the mode. So now I will show you the working of the telemetry. So this is in mode 3 now, and you can see the satellites are changing. So first I will start the headlock and we should see an L, yeah, and then I will change the mode to mode 1, yeah. So as you can see, the telemetry works fine. You can see all of the parameters correctly. Now let's talk about the changes I made for this to get to work with the HC12. So let's talk about the changes which I made in the program. So the only change I made to was the send telemetry data program. Rest of the program is very same. So in the send telemetry data, I have used the same technique which Jupe used in his video, in the original code, that is sending each byte in every loop, just not to mess around with the 400 microsecond loop time. So I use the same technique so that I won't exceed that limit, and I am sending each byte in every loop. Similarly, there is a loop counter and I am sending each byte. The only change is the syntax, because we are sending the data over the I2C bus. So we will be using the h-wire begin transmission, h-wire.write and h-wire.end transmission, and this continues. I have used the same variables, which is telemetry send byte and telemetry temporary byte. As you can see, also I have made sure that the loop counter which Jupe has used is very same, so that I don't have to edit the code at the receiver's end as well. I only ditched the last part of the sending telemetry, which was the changing the telemetry, changing settings using the telemetry, which was extended till 34th loop. So I removed it completely, as I was not going to do that for now. So this code is pretty straightforward. We send each byte. Just make sure to add this tele address integer, which is the address in hexadecimal which you will be using for the Arduino. So now let's switch over to the second code, which is the Arduino code. I have named it the middle boy code. So it is pretty straightforward as well. We include the wire library and software serial library. We start the HC12 software serial, declare the pins, then we create a buffer for receiving the data, and managing the data we will be using two integers. In setup we will begin all the respective functions. In the loop we will simply send the data, and in the void receive event we will receive the data. That is, whenever the I2C bus will receive any data, it will receive it in this way. We receive each byte during each loop, so we will add to it in the buffer. Now I have done this, which is if now the start byte and the end byte I am using is SA and the end byte is P. So I will be managing the index of the buffer using these. So if it detects that the incoming byte is S, then it will make the index 0. Then if it is A, it will make the index 1, and if it is P, it will make 28. So in this way it will arrange the data in the perfect order, which we can then recover later. And we will send this buffer by using a for loop to the HC12 at the ground station. So now let's turn to the ground station. Now I have modified Jupe's code only. I haven't done a lot of my programming. I have simply included the software serial, declared the HC12, and then all of the things are very same. The only change I made was to this. So this was actually while serial.available, I changed it to simply hc12.available, and rest of all the things are same. Start, I only removed the page, yeah, where is that, page 7, where we use it to send the data, like change the settings from the ground station, but I removed it. Rest of all the things are same. Just make sure that the buffer values are matching, because I have to increment each value by 1 because of my weird programming, I guess. I mean, I didn't consider each and every variable and it shifted by 1, so I have to shift each and every index number by 1, and also make sure that the shifting variables are correct. So like shift by 8, shift by 8, shift by 16, 24, because you might get garbage values if you don't do it correctly. I don't know why, but my shift was by 8 bits and that was giving me a garbage value for altitude and takeoff throttle, but I noticed that later and corrected it. So these are the only changes which I made. If you are using HC12 and you follow the same wiring, then you can use my code directly. So I will quickly explain the diagram as well. As you can see, I have included an I2C converter and an Arduino Pro Mini and HC12. The only changes in the circuit, this logic level converter is very important to convert the 3.3 volt logic to the 5 volt Arduino logic, and the Arduino is connected via serial communication to the HC12. We will be using software serial library, so no need of connecting it directly to the RX or TX libraries. So the second photo is this one, that is the receiver station. I simply connected it again to 11 and 12 pins of the keypad shield, and connected the buzzer to the pin 2 and connected the wires positive and negative from this side from under the Arduino. So this is the complete system. I hope you like this video, and in case you make this and it doesn't work, you might have to make your own changes. Thanks for watching.